Hey everyone, it's Miss Lloyd again, here talking about the general binomial expansion. So one of my students today was like, Miss, are we going to have to memorize all of Pascal's triangle? One, you really can't memorize all of Pascal's triangle because it kind of just goes on for forever. You can, I've shown the trick to how to remember Pascal's triangle and make Pascal's triangle. Actually, last year I had students doing races on how fast they could do like to the 15th row of Pascal's triangle or something like that. It was something they did in their free time. My kids are a little weird, but it's all right. I love them anyway. So here, what I'm going to show you is a way to do the binomial expansion, sorry, without having to memorize Pascal's triangle. So this first bit is just kind of an explanation as to what it looks like when we have some binomial, we'll say a plus b, to some exponent we'll call n. So bear with me here for a second. I'm just going to do kind of a general formula of what that looks like. So our very first, we're going to have a to the power of n, because Pascal's triangle always starts with 1, so our first leading coefficient is always going to be 1. A is going to be to the highest exponent, in this case n, and b is going to be to the 0 power. And then we're going to do this pattern that I showed you guys in the last video. And of course, we're going to finish with what would be a to the 0 power and b to the highest exponent, which would be n. So in this situation, it doesn't really matter what our n is or what our b is or what our a is, any of that. This is the general form of what it's going to look like with some dot, dot, dots, because again, we don't know what n is. This is just a general formula. Notice in the bottom, we have 1 times 2, started off with just 1, and then 1 times 2 times 3, and that keeps going as we're going along. So there's actually another way to write this instead of all out, because my students look at this, they're going to be like, miss, no. No, just no. Just no. No. And I know exactly what student would say this, and you know who you are. So anyway, instead of looking at this and just saying no, I have something else to show you. Okay, so looking at this formula, whenever I talk about the k plus 1 term, k is always going to be 1 less than the term number you're talking about. So say I'm talking about the 8th term, then k is going to be equal to 7. So k is always 1 less than what your term number is. So this is where we're getting the k from. K is a little bit of a new situation for us. And our n is talking about whatever the exponent is. So we can use this formula. And the little exclamation point, so most of my students should have seen this before. This is called a factorial. Briefly, that means that if we have something like 5 factorial, we're looking at 5 times 4 times 3 times 2 times 1, and then we stop there. So that's what a factorial is, that's what it does, and if you wanted to do this in your calculator, my students love using their calculator. If you have a TI 84 is what I use. If you hit your math button and you arrow over to where it says PRB, and you arrow down, I believe it's number 4, you will find the factorial button. So you would hit 5, do the math, probability, arrow down, hit the factorial button, hit enter, and then you would end up basically multiplying 5 times 4 times 3 times 2 times 1 all together. My students are also going to look at this and be like, oh my God, miss, really? Seriously? We got a what? What? And actually, I'm going to give them this little gift where this part here, you don't actually have to do all out. You can do a shortcut in your calculator for this, and it is NCK. Now in the calculator, so if you had done the math and the PRB button and arrow down, right above the exclamation point is an NCR button. So NCR. You're using that same thing. So we would be doing the NC. Instead of the R, though, we're going to plug in whatever our K value is. So this is the formula that I'm going to be giving my students on the formula sheet on how to remember how to do this. So this will get them basically the whatever term of the Pascal's triangle. So this part here gives you the Pascal's triangle part. And then the rest would just be looking at the exponents of each of those terms. So just a way to kind of test it, test the waters before we really get through it. If we're looking at the first term, that means our k is equal to 0. So if I were to plug this in just to that general formula, so I've been asked what is the first term of a plus b to the power of n. I can plug this into my situation. So I know my k is 0, n we're just going to leave as n. That's totally okay. So we'll have n factorial over, n minus k. And in this case, our k is 0. And then that's a factorial. And then 0 factorial, if we plug this into our calculator, so notice whenever I did the 5 factorial, I didn't go down to 0, because when I multiply by 0, it all just goes away. So 0 factorial is actually 1. Nice thing to look at. And then a and minus k, and again, our k is 0, and then b to the 0 power. So simplifying this out, I know n minus 0 is just going to give me n factorial, and 0 factorial is just 1. So now I basically have n factorial over n factorial, which is just going to be the same thing. If you have 5 factorial over 5 factorial, it's going to cancel out and just give you 1, so that goes away. N minus 0, again, is just going to give us n, so I have a to the n. And anything to the 0 power, as long as it's not 0, we're going to assume that b is not 0 in this case. Otherwise, why would you be doing the binomial formula if b is 0? And that would just give us 1, so then our first term will be a to the power of n, which is what we got here at the beginning. So just kind of what that would look like if we're plugging stuff in. When it comes to sigma notation, this is just another way to write it. So if we're doing something like a plus b to the n, and this is something that someone could ask you, hey, what is the whatever term of this, they can show it to you this way. So n. And so this is basically the way that I've shown it before, just now we have a summation sign saying that we're putting all this together for the sigma notation. So every single term. So this is how to get just the individual term. And then that summation sign, that sigma sign, is telling you that you're adding all those together. So it's just showing you the big block of this binomial expansion. So for this first bit, we're just kind of playing around with the factorial stuff. So for my students, this would be a great way to practice plugging this into your calculators. I like to look at it in a more logical standpoint where I don't have to use my calculator. So if I have 20 factorial, that means I'm multiplying 20 times 19 times 18 times 17, and so on and so forth until I run out of breath and I kind of run out of room. But we get the picture. And 18, it means I'm multiplying 18, 17, 16, 15, and so on. So here we can see, oh, if I got an 18 over 18, I can cancel that. 17 over 17, 16 over 16, 15 over 15, and the dot, dot, dot is basically all the numbers that come after that, so that would also cancel, meaning I'm pretty much just left with my 20 times 19. And then when I plug that in, we end up getting 380. And we're done. So this next bit, this looks a lot like what we would see in that situation. So you can either plug it in 8 factorial divided by, and you want to put this in parentheses, 5 factorial times the 3 factorial. If you don't put it in parentheses like that, it's likely you're going to do the division and then multiply everything by the 3. It's not going to multiply with the 5 first, and so the 3 won't be dividing. You'll end up with some issues. This is also going to be the same as if my 8 was the n, it's in the n's place, and the 3 would be my k. So this means if I'm doing the NCR button, so you can show it both ways, you can play around with your calculator, do it both ways. So we would have 8, our combo button, it's technically what it's doing, and the 3. And so when we do that out in our calculator, we end up with 56. Not too crazy. But yeah, these are going to be the same thing. They're interchangeable, so depending on how you want to look at it. Next bit, go ahead and do this out. It's going to give us 45. Again, make sure that you're putting these parentheses, do the 2 factorial times the 8 factorial, then do the 10 divided by all of that. And then this last bit, it has a variable in it, so I kind of want to write this out. So here on top, I would have started with an x plus 1. Because it's a factorial, that means I'm now going to be multiplying with that the thing that comes after or before it. So 1 less than that, which 1 less than x plus 1 would just be x. And then I'd be multiplying 1 less than that, so x minus 1. 1 less than that would be x minus 2. And then I keep going, minus 3, minus 4, minus 5. We don't really know what x is, so we need just kind of a representation of that. And it could be 7, it could be 432. We really have no idea, so we're just going to go that far. And on the bottom, I'm going to be starting with x minus 1, and then going for everything after that. X minus 2, x minus 3, x minus 4, so on and so forth. So here I see that I can cancel out my x minus 1s, my x minus 2s, and everything that comes after that, which means I'm really just left with the x plus 1 times the x. Distributing that x in, I would end up with x squared plus x. And then that's all we can really do from there until we actually know what x is. All right, so here we want to write the first 4 terms in the expansion for each of the following and write the last 3 terms. So doing the first 4 terms to begin with. So typically whenever I'm doing this, in the last video I like to start with Pascal's triangle first. So when I'm doing Pascal's triangle, instead of trying to find the entire 18th row, which seems really freaking ridiculous, especially if I'm just looking at the first 4 terms, I'm going to use that combo button instead, which means I need to know what my k is. So remember, k is always 1 less than your term number. So if I'm looking at my first term, that means k is going to be equal to 0. So if I'm looking at the Pascal's triangle part of my first row, that means that I'm doing my, okay, in this case, my n is going to be 18. So 18 combo 0. This is going to give me that part of Pascal's triangle. If I'm looking at the second term, I'm going to be doing the same thing. So in this case, k would be equal to 1. So I'm going to the next spot. So I'd be doing 18 combo 1. And then so on for the third and the fourth. I also need to figure out what's going to happen with my first term. So in this case, a. So when we start out, remember that first term always has the highest exponent, so I'll have to the 18. As it keeps going down, that's going to go down as well. So as we get to the second term, it's going to turn to the 17th. It's going to be subtracting every single time, which is where that k minus 1 came from, or that n minus k, sorry, came from in this formula here. So our first term, it would be 18 minus 0, so it would just be 18. Second term, 18 minus 1, meaning we have 17, and so on and so forth. And then the second term is going to follow whatever the k is. So remember, we always started off with our second term being to the 0 power. Notice how that matches my k. And then it goes to the first power, again, matching my k. And then it grows from there, always mimicking whatever the k is. And then we're going to simplify it out. So then 18 combo 0, whenever you plug this ends up being 1. And then we have a to the 18th, and negative x to the 0 power is just going to give us 1. 18 combo 1 is going to give us just 18. And then we have a to the 17th, and negative x to the first power is still going to be negative x. So I'm going to move this over a little bit so that I have room for my negative sign. And then when we do 18 combo 2, we would end up with 153. So this would be the 18th row of Pascal's triangle. The third number would end up being 153. And then a to the 16th power, and negative x squared would give us just a positive x squared. And then our last one, we do 18 combo 3, we would end up with 816. A to the 15th power, and then Negative x cubed would leave us still with a negative, and then our x cubed. So these are our first 4 terms. And then when it wants us to write the last 3, so writing our last 3 terms, I know my last 3 terms are going to mimic these same situations here. Say we don't really know what that might be. So my last 3 terms. So I know I could do, 1, -18, and 153. I know those are going to be my coefficients for each of those terms. If you don't remember that we have that symmetry with Pascal's triangle, you can always do the combo as well. So for our very, very last, we're going to have 18 combo 18. For second to last, it'd be 18 combo 17, and then 18 combo 16. So we'd always end up with a 18 combo 18 for this situation. You can't go any farther than that. So if you didn't remember that from before. And I know that my a is always going to end up being to the 0 power, which means before that I'd have a to the first, a squared. And then my x is going to be at its highest at the very last, so x to the 18th. And it is a negative x to the 18th, so it would keep it positive. And then this would be negative x to the 17th, which is where the negative 18 came from. And then x to the 16th. And that would have ended up being positive. So these are our last 3 terms. And we're on to the next bit. So this is something you can pause, try on your own. I'm going to speed through it a bit, but still making sure that I show each of those steps. All right, so now we've got our first 4 terms, and we're ready to find the last 3. So again, I'm going to be using this situation, and I did go back and I kind of changed the what I was going to do, so I was just going to leave it as 32x, but I wanted to make sure that we had the 1, the 16, and the 120, because I know that those are going to be the terms that are going to be from Pascal's triangle. So I want to make sure that I have those around before I do all the multiplication, so then I don't have to do it out again later on. And again, for the last, my 1 is going to be to the 0 power first and the second. And then my 2x is going to be to the 16th, 15th, and 14th. And then we're finished. And so we've got our last 3. So they're wanting things that are very specific. So looking at this, it's saying x is the first term in the binomial, so I know this is my a situation. It wants us to find the entire term that contains the x to the 5th. So if I want to kind of copy that down. So I have my n combo k, a to the n minus k, and b to the k. So this will help me find an individual term. So I know that I want the n minus k to be 5. And I know that my n is 12. It's whatever our exponent is. So I know I can start plugging that stuff in, the 12 and the combo. In order for the 12 minus k to be 5, that means I had to have k of 7. So my k is 7, which means I'm looking at the 8th term, because remember the k is 1 less than what we're looking at. So then I have my x, again we know that's to the 5th, and my y value, which is in the place of the b, is going to have the same exponent as whatever k is. So in this case, it's going to have 7. Also, something that I want you guys to keep in mind is that anytime we're doing these, my 2 exponents here always, always, always add up to whatever the n is, every single time. So if we go up further, if we're looking at these, my n here was 18. And so we had 17 plus 1, 16 plus 2, 15 plus 3. All of these add up to give us 18. So those exponents will always add up to give us 18 whenever we are able to see both of those sets of exponents. So now I just type this out. So in my calculator, I would do 12 combo 7, and I would end up with 792, x to the 5th, y to the 7th, and we're done. A little bit easier just to find the one term instead of a bunch of them. Next, we're finding the term containing y to the 3rd power. Because y is my b term, I know that this is going to be my k, so my k is equal to 3, meaning I'm looking at my 4th term. My n is 8. So if I'm doing the combo thing, I'll have 8 combo and then my 3. And then my first term is 2x, and that's always going to be to my n minus k. So in this case, I have 8 minus 3. And then my b term, the y, is going to have the same exponent that it asked for here, so my 3. And then going through this, my 8 combo 3 would end up giving me, oh, and we have to make sure that we pay attention to that's a negative y, almost forgot it. 8 combo 3 is going to give me 1,792. This will end up being 2x to the 5th power. And because I have a negative y cubed, that means I'm going to have a negative out in front here. Oops, nope, this is 56. I totally did the multiplying by 2. My bad. And then, so this ends up being y to the 3rd. I'm just going faster than what I was planning on originally. So the 2 to the 5th power will give me 32. And 32 times that negative 56 will end up giving me 1,792. X to the 5th, y to the 3rd. And then we're done. So make sure you're not doing multiple steps all on top of each other. Pace yourself. I obviously wasn't. I'm also going a little bit insane in this room. Day 11 out of 14 in quarantine. And then after the 14 days, I can leave. It's supposed to be nice on the 15th day so that I can go outside and be in the sun and maybe take a walk or maybe walk the dog. That'd be really nice. Anyway, next bit. So now they want us to find the 5th term. So remember, k is what we need, and k is always 1 less than what our term number is. Because we're looking at the 5th term, k is going to be 4. My n is that 6. And then my first term is 1. My second term is at y squared. So I'm going to start plugging this stuff into the combo formula. So I've got 6, which is my n, combo 4, the k, and then I have 1 to the n minus k, and then my b term, which is my y squared, is always going to be to the power of k, so in this case 4. Doing this all out in our calculators, at least the combo part, the 6 combo 4 is going to give us 15. And then in 1 to whatever power is just going to be 1. I'm going to ignore it. And then here we have an exponent to an exponent, so we're going to multiply those. And this will be y to the 8th power. And that's our 5th term. And then we're done. Ta-da! All right, so if you're my student, you can go to your LMS page, and there will be the homework assignment for you. This is the last of the chapter, and so tomorrow we are going to be doing a review, and then on Friday will be our test. Those of you who are not my students, you can now laugh maniacally with me at my students having to take a test. But I organized it very well so that they would have the test the day before spring break, and then they have no math to do over break. So I'm actually a kind person. Cue the angelic music. Or don't. That's totally fine. Also, if you're my student or not, please like and subscribe and share this with whoever you think might need it, especially this end part, because I am going nuts. Maybe if other people see that people are going nuts and it's not just them, they'll feel better about going nuts. Spread the love.